Okay, reflection. There are two types of reflections. Reflection over the x-axis, reflection over the y-axis. Also known as folding over hamburger, which is over the x, and folding hot dog, which is folding over the y. Do you understand that? Okay? Now, if you are reflecting over the x, meaning folding it hamburger style, this means what you're doing is technically putting the negative in front of the function, distributing the negative across the entire function. What this means is your y values change. Your y values change. You're reflecting the function over the y-axis, meaning you're folding it hot dog style. This means you're putting a negative every place you see an x. That negative goes with the x and only the x. It does not go to every term on the function. So this means only your x values change. Now, what I want you to do is I want you to visualize this. Usually, whenever you guys are able to visualize this, you do great with this concept. Okay? So I want you to look at the point -1, 2. Do we see the point -1, 2? Right there, second quadrant, blue dot. I want you to fold that thing over the x-axis, hamburger style. If you're folding that hamburger style, where is that point going to land? It's going to land right here, being the coordinates what? -1, -2. Now you tell me, what has changed in that ordered pair?
Y value.
The y value changed. Well, I want you to go back to what we just talked about a second ago. When you reflect over the x-axis, what changes?
The Y value.
The y value. I distribute a negative to the whole entire thing, and that entire thing makes the y value change. Do we understand that? Can you visualize it? Did you see it? Did you see that the x value stayed the same? Now I want you to fold that same dot, -1, 2, this time over the y-axis, hot dog style. At what point do you get? 2. I'm going to have the point 1, +2. What changed this time? Did both values change?
Oh, yeah.
No, only thing that changed was the x coordinate. It went from being negative to being positive. Well, look at that. Look at this definition. If I'm replacing a negative x with an x, it's going to go from positive to negative. Durger, you're way too comfortable. Get uncomfortable. You're going to pass out back there. Okay? Do we understand why the x coordinate changed? Okay? Now, go to the other point. If I'm folding this point 6, -7 over the x-axis, where's that going to be at? Over the x. Hamburger. 6, 7. I'm going to go. It's going to be right there. I have the point 6, 7. Do we see that? What changed with the y? Well, that's because I'm flipping it over the x. Whenever I'm flipping over the x, what changes with the y coordinate? Do we understand that? If I'm flipping it over the y, what happens then?
Negative. -6.
-6, -7. What changed? Only the x changed. Now, we're going to apply that same concept to functions. Do we understand that? First, we apply it with points. We can visibly see it happening. Now, we're going to apply it with functions. Given f of x is equal to 3x plus 3, find the function g of x, which is the reflection of f of x over the y-axis. So if I'm going over the y-axis, I'm folding hot dog style. And when you fold hot dog style, what happens is the x and the y point change. The x point changes, which means g of x is equal to f at -x. Because the x value is what's changing. So every place I see an x in f of x, what do I replace it with? Negative x. So my function is 3x plus 3, so I'm going to replace that x with a negative x to give me the -3x plus 3. That is a reflection over the lovely little y-axis. Do we get that? That's what g of x is. Do we get that, yes or no? Let's do it again. Given the function f of x is equal to 2x minus 1, find the function g of x, which is the reflection of f of x over the x-axis? Well, visualize the coordinate plane, visualize the point, and fold it hamburger style. You fold that point hamburger style over the x-axis. What changes?
Why?
The y value changes. Now, how in the world do you change the y value? In order to do that, that means g of x is going to be equal to negative f of x. So what's f of x defined to be? 2x minus 1. In every place I see it, what do I do with that negative? And I distribute it to every little term inside there. So that's negative 2x plus 1. That is going to be my new function. Do we understand that? Do you see how I'm using the definition of flipping over the y and flipping over the x to be able to get the new functions? Yes or no? Good. Now let's keep going. Now this time we're doing combining transformations. It says the graph of g of x is the graph of f of x equals 4x. Compressed vertically by a factor of 1/2. What in the world does that mean? Yeah? It's shrinking. So here's my mode. Am I a travel mode or am I a serial bowl? I'm turning into a serial bowl, but how do I turn that into a serial bowl? Compressing and stretching means you're multiplying by a factor, right? So g of x is equal to 1/2 times f of x. But what's f of x? 4x, so that's going to be what? 2x so far. Do we see that? I've compressed it by a factor of half. And then what does it say to do? What's it say to do next? Reflect it over the y-axis. Okay, visualize that coordinate plane in your head again. If I'm reflecting over the y, that means I'm folding hamburger or hot dog. I'm folding hot dog style over that y, which means what changes? Well, x's change. So how do I do this? I'm going to put, every place I see an x, I'm going to put a negative x. Do we see that? So what's that going to give me? So g of x is actually the function negative 2x. The graph of g of x is the graph of f of x equals 2 of x stretched vertically by the factor of 5. What in the world does that mean? This means that I'm going to have g of x is going to be equal to 5 times f of x. Well, what's f of x? 2x. So what's 5 times 2x? So I have 10x. And then what does it say to do? And then reflect it over the x. So am I floating hamburger or hot dog? I'm floating hamburger, so what happens to my point?
The y value changes.
The y value changes, so therefore I'm going to distribute a negative to the entire function.
So it's going to be negative 10.
So it's going to be negative 10x. Now, is this always going to be like that? No. The point is do you understand where to put the negative? Is it inside of the x, or is it you distribute it to the whole thing?
It's being distributed to the whole thing. Why do we use your close rules like that? Why does the whole equation change?
Okay, let's talk about that then. Why does the whole equation change whenever you're reflecting over the x? Because what was the parent function of this? There's 4 parent functions. We have the lines, the u's, the parabolas. We have the medians, which is the absolute values, and we have our spaghetti, which is our x cubed, and we have the lines, which is just x, right? So what was the parent function of this? What was f of x? F of x equals x. That's mx plus b, right? So let's think about that. If I have mx plus b, and if I replace x with a negative, that means my slope has become negative. So instead of going up the mountain, I'm now going down the mountain. If I distribute a negative, it's the same concept. Instead of going up the mountain, I'm going down the mountain. That only works with the line. Does that make sense? If you have a parabola or your spaghetti function, okay, things are going to be a little bit different. All right, moving right along. Now, This says, what transformations change the graph of f of x to the graph of g of x? What did I do to 2x squared to turn into 6x squared minus 1?
Equal to 5.
Why did I stretch it by 3?
Because it takes
So what you're telling me is I have to take my f of x function and multiply it by 3. So 3 times 2x squared is going to give me the 6x squared. Well, that's perfect, but is it giving me what I wanted it yet? Now, what did I then have to do? I have to go down 1. So what you're telling me is I stretched this thing by factor of 3 and then I went down 1 unit. This is the answer that I'm looking for. Because that's what I did to f to get g. Does that make sense? I stretched f first by a factor of 3, and then I pulled the whole graph down 1 unit. Okay, I want you to work from left to right. What's the negative do? Reflects over y over the x. Oh my word, Sierra. Bless you, my dear child. You've done 100% perfect. What did she just say? It reflects over the x, not the y, because what?
It's not in the absolute.
It's not within the absolute value of the x. So this is going to be reflected over the x-axis. Then what does the 6 do?
It stays.
Stretches it by 6. What does the plus 9 do?
Goes to the left.
Goes to the left 9 units. And what does the minus 2 do? Goes down 2 units. And what's my parent function? Absolute value of x. No one is dumb. We're just not trained this way. So we have it's going to take time to understand it.
Oh my god.
So, from left to right, what does the 2/3 do?
Distribute.
It progresses by 2/3. What does the minus 6 do?
It goes to the right six.
down.
Goes to the right 6. What does the 3 do?
Uh-oh, I don't know.
It's part of the parent function.
It's part of the parent function. What is that parent function?
X cubed
X cubed. What does the plus 8 do?
goes up.
Goes up 8. Do you see how I never once went backwards? I kept moving from left to right. Do we get that?
Yeah.
What's that?
Everything opposite works with negative, so like you're the right.
Okay, that was the last example on the notes. Now, what do I want you to do? I want you to get out Monday's homework.
Hey, I did
Monday's
that.
homework. Let's get out Monday's homework. I do 6 worksheets in practice. It's not one I made, it was ones in the textbook.
What
We're
we
all
weren't
different.
supposed to do finishing grading on?
The ones I wanted you to finish up by listening to the video yesterday in class, but since nobody listened to the video accurately to finish their notes, therefore they know how to do the worksheet. Okay. Problem number 1. How is each function related to y equals x? What happens to that? Goes up 2. So if I'm doing this, it says number 1 going up 2 units, and then it said to graph it. Well, this right here was y equals x, so there's my line. Yes? We actually did x squared. I didn't mean to do that.
Larissa said, okay.
Now, if I'm going up 2 units, that means I'm going to go. Do you see it? Yes or no?
Sure.
Yes?
Yeah.
Number 2, what's happening with number 2?
Down to.
It's going down 1.2. So here's my original line. There's my original line. I'm going to go right here. There's my new line. You see that? That's all you're doing. You're pulling the whole thing down. Number 3, it says make a table of values for f of x after the given translation. So what's that going to be?
Negative 2.4,
down
0, 3, 1, 5, 3, 6, 4.
What are you going to do to every one of the f of x values? subtract 2. So negative 7 minus 2 is negative 9. Negative 5 minus 2 is negative 7. Negative 2 minus 2 is negative 4. 0 minus 2 is negative 2. 1 minus 2 is negative 1. How many of you got that?
Hold on a second.
That was in
Oh, I
here.
know what I did.
I like that.
Okay. Number 4. What do you get for number 4?
Negative 2.
What did you just say?
5, 6, 7, 8, 9.
5, 6, 7, 8, and 10. That is correct. Number 6. It says write an equation for each vertical relation or translation of y equals f of x. Why are they telling me y equals f of x?
Oh, I got you.
Why are they saying y equals f of x? They're telling you that y is a generic parent function. Do you know which parent function it is? No. The question is it exactly the same for each parent function no matter how you shift it? Yes. So it says, how do I vertical translate down 1/4 of a unit? The function y equals f of x. So tell me what the equation will be.
So 1/4.
So f of x minus 1/4.
Y equals f of x minus 1/4 is the correct answer. How about number 7? 5 units up. Y equals f of x plus 5. Do we understand that? Okay, number 8, what's happening to that function? It's going to the right 5. Now, how do you graph that? This is your original parent function. If you're going to the right 5, there it is. Do we see that? What about number 9? What's happening to it?
Left 1.8.
Going to the left 1.8, so here it is. Do we see that? Okay, number 10. I would have cheated. It says maybe table values for f of x. Well, there's your f of x, your points, right? Make the points. Put them up there. Then it says to make f of x minus 2. What's f of x minus 2 doing?
Subtract it from the
Well, because we're lazy, I'm just going to take 2 points away. Down, every point. Bam, bam, bam. Write the ordered pairs. It's that simple, right? It's that simple.
Minus 2 that way.
No, that's not what it says to do. Minus 2, that would actually be f of x plus 2 in parentheses. You see it's out of the parentheses?
Yeah.
Yeah. That's why you don't go to the left. You only go up or down. In this case, down. Does that make sense?
That sort of kind of.
If I wanted it to be f of x plus 2, then I would go 1, 2, 1, 2, 1, 2, 1, 2. I just totally used the wrong one. 1, 2. And then this would be 1, 2. Then it would be that. You see that?
I'm just saying I did both.
Yeah, I don't want you to do both.
Blue and the green.
Okay? The green is just going to be the f of x. And the blue is going to be the f of x plus 2. There's a difference. Okay? There's a difference. Turn it over. The vertical stretch by a factor of 3. Well, what's that equation going to be? Y equals 3x. How about a vertical compression?
y.
Y equals 1/5 x. Now 13 is where things start to fall apart for y'all. F of x is equal to 4x. G of x is equal to x over 2 minus 1. Now, what I want you to do is to tell me, what did you do to this thing? How did you go from 4x to a half of this? How did you compress it by 1/8? Now I want you to think about this. Compression means you're multiplying by a fraction. And I needed to turn into 1/2 x. Why? Because this is a 1 I understood to be there. Right? So the 4 was in the top, and I need that 4 to cancel out. So the only way that can cancel out is if I have a 4 in the denominator, right? Again, I need that to turn into a 2, though. So I need to not only have a 4 down there, but also a 2. And what do I want to have on top? A 1. So what this number right here multiplied together gives you the 1/8. So I know I'm compressed by 1/8. Did we see that? I'm compressed by 1/8. Then what did I do? I went down 1 unit also to get me that lovely little -1. Do we understand that, yes or no?
Yeah.
Okay, the next one was 5x and g of x is going to be -2 times 5x minus 1. Now I want you to look at this and ask yourself, what is going to be my parent function of this thing? Well, what's the original? 5x and 5x. So what did I do to 5x first? What did I do first, though? It's in parentheses. Do we see that? Since it's in parentheses, I know that I have to go down 1 unit first. Then I stretch that quantity by what? 2. 2, and then I did what? What's the negative do? Reflect it over what? Why is it over the x-axis? Because it's not inside the parentheses. Do we understand that, yes or no? Remember, if it's inside the parentheses, it's reflected over the y-axis because x is what changes. But when it's not inside the parentheses with the x, it's outside, that means it's reflecting over the x-axis, changing the y value. Okay, what's next?
Graph.
Number 15. Number 15 tells you, it says write the equation for f of x and g of x. Well, first of all, I have to write 2 equations. What do we have on these graphs? What are the parent functions of these equations? Are they lines, U's, spaghettis, B's? They're lines. What's the equation of a line? Y equals mx plus b. So what's my b value on my f function?
However many you do.
My b value is what? Look at my b value on f of x. F of x, my b value is going to be
1,
0,
4, -4.
0, -3.
-3.
What's my slope? Well, my slope is going to be up 1 to the right 1, up 1 to the right 1, or I should say to the left 1, which means it's going which direction? Downhill. So this is going to be -x, is -1, is going to be my slope. To give me y is equal to -x minus 3. That is f of x. Do we see that, yes or no? G of x. What's my b value there? My b value there is going to be 0, 3, and what's my slope? 1 to give me the equation x plus 3. Now, these are my 2 equations, and then it says, then identify the reflection that transforms the graph of each of f of x to g of x. Well, my question to you is, can I pull out a -1 out of this thing and make it equal to this over here? Sure I can. If I pull out a -1, I'm left with x plus 3 on the inside, correct? Which means that negative, did it go to both terms or one term?
1.
It goes to both terms, which means am I reflecting over the x or am I reflecting over the y? I'm reflecting over the x. Clearly, if you fold this hamburger style, what happens to those little graphs? Look at your paper. They what? They match up. So you can clearly see that this is a reflection over what? The x-axis. Do we understand that? Now, 16, you guys can do that one. I already did 15 for you. You guys can do 16. 17. F of x is equal to x plus 3, and g of x is equal to x minus 2. This is graph each pair. How do you graph that? How do you graph x plus 3? What do you graph first?
Your original line.
You graph your y-intercept 0.03. Then how do you graph another point? Up 1 over 1, up 1 over 1, up 1 over 1. There's my line, yes? And then it's saying, what do I do to x plus 3 to make it into x minus 2? What am I going to do to that thing? I'm going to drag it down 1, 2, 3, 4, 5 units. So this goes down 5 units. That is what you're doing to those functions. Because the parent function of this function would be x and x. Do we see that? How many units are there between those two functions? 5 units. Do we understand Monday's homework? Okay, get out last night's homework. Get out last night's homework. Now, the direction on last night's homework says compare the graph of the function with the graph of f of x equals x squared. Number 1, I'm comparing it to x squared. So what's happening? Up 2. What should you have written? U2. That's a good thing. Number 3, what should you have written there?
R2.
Going to the right 2 units. Number 5, what should you have written there?
Left,
Go from left to right, folks. I'm going to be very picky about this. What's the negative do? Reflects over the x. Go to the next thing. Left 6. Go to the next thing. It's the parent function x squared, which we already have in the direction. Go to the next number. And it's going to go down 9. Do we understand that? Number 7. Compare the graph of the function with the graph of f of x equals absolute value of x. So what does this do? Left 2. Number 9. What's happening here? Reflect over the x-axis, because it's out front, and then compress by a half. Do you understand that? Number 11, the directions say identify the parent function f that is related to g. So I have g of x is equal to x squared plus 12. So what is my parent function?
X squared.
What is it? X squared. Good job. Then it says describe the transformation from f to g. So what did I do from x squared to get x squared plus 12? Up 12. Very good. Number 14. G of x is equal to negative 2, absolute value of x minus 1. What's my parent?
Absolute value.
The absolute value of x is my parent. So what am I doing to go from the absolute value of x to the g function on your paper? What's the negative mean?
Reflect over here.
Reflect over the x, then what?
Go.
What's the 2 do?
Goes down to.
Stretch of a 2, and then write 1. Okay? Number 15. G of x is equal to 6 minus absolute value of x plus 5. So what's my parent function? Now, from left to right, what's the 6 do? No. Why does it go up 6? Guys, if you have to do this, back that plus 6 at the end, because the only thing that's attached by multiplication to the absolute value is the negative 1 in front of it. Okay? So that 6 actually goes up 6 units. The negative reflects it over the x. And then the plus 5 does to the left 5 units. Turn it over. Number 20, write the transformed equation g of x with a given translation. So I give you f of x is equal to x. What is that? It's a parent function. It's y equals x plus b. So it's the slope of 1 with the y-intercept of 0. Okay? It says reflect over the y-axis. So if I reflect it over the y-axis, what changes? The x value changes. So if I'm reflecting that over, I have to have negative x. Do we see that? Then it says to do what? Compress by a factor of 2/3. So if I'm compressing this by 2/3, what do? Negative 2/3 x. And then it says it's up 6 units. Yep.
So for the answer, would it be g of x or x?
This is going to be g of x. F of x cubed. What does x cubed look like? Spaghetti. Okay? It's stretched by a factor of 4. What's that give you? 4x cubed. Then what? It says reflected over the y-axis. So if it's reflected over the y-axis, what changes? X or y?
X.
X. So every place I see an x, what am I plugging in for? So this is going to be 4 times negative x cubed. And what's a negative times a negative times a negative?
5. Negative.
A negative. So what this actually is going to be negative 4x cubed. Do we see that? Then it says left 2 units.
So minus 2 or add 2.
Right, it should be in parentheses.
Okay, I'll show you something. Hold on. In parentheses, it says to the left how many units? 2. So what do I write there?
Or add 2.
Plus 2 cubed. Then what? Down 9, so that's minus 9. Do we see that? Now, why does that look like it's reflected over the x-axis and not the y-axis? Because you tell me, if I have this lovely little picture of spaghetti, and if I fold that hamburger, this part goes up and this part comes down, correct? Okay. This is folding over the x-axis. Now, what if I fold that red one over the y-axis? This part, oopsie, sorry, my elbow got it. This red part in the first quadrant goes where?
To
To this.
Yeah.
And then this red part in the third quadrant actually would go to the fourth quadrant. What do you notice? That when you reflect the x cubed, the spaghetti function, over the x or the y-axis, they look exactly the same. Because that's what we call an odd function. Do you understand that? It's symmetrical according to the origin, which is both the x and the y-axis. Okay? So that's why in this case, it looks like it's reflected over the x, because they're exactly the same. Okay? Not on that one. 23. Describe the transformation of f of x that would produce g of x. So I have f of x is equal to 15x minus 13. G of x is equal to 3x minus 10. So how am I going from 15x to 3x?
We're going to have 5.
Compressed by not 5 because that's a whole number, but 1/5. So I compress by 1/5 because compression means a fraction. Then how am I going from negative 13 to negative 10?
Compressed by 1/3.
Oh, negative 13 is down here. Negative 10 is up here. So be very careful. We're going to add 3, which means we're going up 3 units. Now 25. F of x is equal to x squared plus 3x minus 2, and it says to reflect over the y-axis. So if I'm reflecting over the y-axis, what changes?
Your x value.
The x value. So every place you see an x, you're actually doing negative x. Right? So what's negative x times negative x? Positive x squared minus 3x minus 2. There's your new function. 25. Now, this is exactly like Damien's problem that we talked about earlier. What happens to f of x minus 3, f of x plus 1, and then draw them. Have a great day. Better be done tomorrow.